and we start to talk about some problems in your code, some code flows or anti-patterns. And I will show you the most hard problems in code, and in practice you will try to refactor, to find and to refactor these problems. And today I will show you maybe the most simple, maybe the most hard type of problems. It's a duplicate code. I know that you can create it, you saw it a lot. And there are two types of duplicate code you can see in this slide. First is explicit duplication. This is exactly the same code. You can create it when you press Ctrl C, Ctrl V in your laptops. And I understand that usually students make a lot of code with this type. And the second is implicit duplication. It looks different but does the same thing, and we should solve this problem too. So, little question here. I will use the Java language because it has very simple syntaxes. That's why I think that you will understand everything. And here I have code with some class customer, and I create new object of class customer with name John Johnson and do something with this customer, and then I create new customer Peter Parker and do the same. Please think a little, and I can tell you that the solution is very simple, and please tell me how we can solve this problem, how we can remove the duplication code here. We have single class, it's a customer. Maybe another mini solutions or suggestions. Guys, it's very yeah, you're right, but why class? We need just only method for loops. Not class. I think class is too much for this situation. Yes, when we have the same code with some different little things, like here we have different names, we can create method and call this method in the both places in this code. In books about refactoring, we call this method of refactoring extract method. And if you try to use refactoring instruments in your IDE, you have such instrument like extract method with this name. It means that we create new method and move code to this method and just use this code in place where we need it. This method of refactoring, we can apply it for some separation of very long methods, for example, to remove the duplication, but we should always remember that new method should have a clear name, because if you will create new method with name like method 1 or method 2, you will make your code not so good. That's why it's important to remember about naming. The name of new method should explain what the method does. Then another case, when we have some hierarchy of classes, Like in this example, we have class unit and two children, class soldier and class tank. And soldier and tank have methods like get health and get health, and these methods are the same. What we can do to remove this duplication? It's very simple, guys. Yes, you are absolutely right. And this method of refactoring in books we call pull-up method. It's very simple. Who knows that refactoring it's not so hard? Yes, and we just use pull-up method. We move these methods into the parent, and we can use this method in a soldier and in a tank class. The next example of code duplication, it's a more complex case, and here we have two methods, look different, but they do almost the same thing. Here I have the example. I have parent class shop item and children device and book, and both of them have a get device description method, and inside this method we have some logic to make the string description of current device or book. And you can see that both methods are equal, but with some differences. For example, we have the same line like shop item description. We have something like price, and we have differences here in the line with device with name and book with title. So it's duplication of code, and here we should use, to remove this duplication, more complex method. We can use extract method with new template, with template method. I hope that you remember what is pattern template method, but if you don't, I can show you this diagram. And if you don't remember what is it, I think it's necessary to Google it, to read about it, because in the third year of university you should know the patterns, you should understand them and use them if you need it. Template method, it's a behavioral design pattern that defines the basis of algorithm and allows children to redefine some steps of algorithm without changing its structure as whole. Here I have some parent class or abstract class, and inside this class I have a method with some steps, and I can separate our algorithms like this in some steps. For example, first step, shop item description. The second step, it's a device with name. The third step, it's a device price, and moreover. I can move this get device or get book description into the shop item and override some steps in which I want to use another code. Here I have the same step 1. It means that it's not necessary to override step 1. I can use the realization in shop item. But the step 2 in device and in book will be different, because here I have device with name, here I have book with title. That's why I can override this step inside class device and class book. The third step, here we have device price and book price, but that's why it's better to override them. And the counting of price differs too. That's why it's better to override these methods, these steps. So I can create the get description inside shop items, separate it into some steps, and override these steps in children classes, but not all of them. If I have the same step like here and here, I will not override them. If I have different steps, I can do it. I hope that it's clear for you. And if you don't know or don't understand it, you can read about this method of refactoring. In every slide about methods of refactoring, I have such icon with a text. It means that in book of Fowler, it's a refactoring book, in page 361, you can find information about this method of refactoring and read it in the first source. And I hope you will understand everything. It's more complex method of refactoring, and it allows us to remove duplication, explain the logic better, because we separate our algorithms into some steps, and every step can have good name of this method and explain us what we do in this step. And it allows us to change something only in one place. But sometimes it can complicate the project if we have too much steps in one algorithm. That's why always thinking, do you need this method of refactoring or not? Another case, more complex, but it's very close to previous, and here we have such hierarchy, like test case as a parent class, and two classes with tests, but here we have the same methods with only one difference. In this method, we create new object of class Doom Builder, and here we create new object of class XML Builder. Only one difference in these two methods. Again, to solve it, we can use previous instrument like template method, but here we will have special step to create these two objects. And when we create the method which only creates something for us, it means that we use factory method. Factory method, it's a special pattern again, which we can use when we want to hide some logic about creation in special method. That's why when we want to solve this problem, this duplication code in two classes, we use two patterns in one place, factory method and template method. And we will have a hierarchy like this one. This is the first variant, and when we will refactor this situation, we will have in our parent class new method, create builder, and we use this method inside our method, and we can override this create builder in children to make new Doom builder here and new XML builder here in this class. In this situation, we use two patterns. Factory method, because this method, it's a factory method, because it's the goal of this method is to only create new object. And template method, because we use some template here in the parent class. I understand that it's a complex, but you can read about it in a book with this author in the page 116. This slide is about factory method. If you don't remember it, And again, if you don't know, you should Google it and learn about what is it and how to use it, because it's very famous and we use it very often. And again, when we refactor some code with such methods, we can reduce code duplication. We can effectively indicate when we create something in our code. But sometimes, if we should to create very very complex object, we need to pass a lot of parameters in our factory method to create this object. But I think that it's not a problem. So the next case of duplication code, and I can say that in modern languages we sometimes don't use this method of refactoring, because in modern languages we have special variants of constructors. But for example, in Java or in C# we can find this problem. Here we have duplication inside these constructors of our class, because we want to have variants of a constructor with different number of parameters. And to implement all of them, we need to copy the logic of creation our objects. That's why here we have duplication code. Of course, I don't like this code. I want to solve this problem and remove this duplication. I hope that you understand why duplication code is bad. And here I can use a special solution. It's a chain constructor. What is it? You can find it in the modern programming languages, and it looks like here. I can create the most important constructor, like here. It's a third constructor, and it create it determine all values of fields of my object. And I just use this constructor in another constructors. Here I call this constructor, here I call this constructor, and it means that I have the chain of constructors. If I will use this one, it will run this, and after that this will run the third. If I will use the second, it will use the third constructor again. Each constructor calls the next, and the main logic is only written once here in this constructor, and we remove the duplication code in this situation. And the most complex case for today's lesson. Today's lesson will be short because you have big homework and you need time to solve it. It's the last case for today. And here I have some hierarchy of classes, like abstract builder, and here I have children, XML builder and DOM builder, and these two classes uses some nodes. XML builder use tag node. I hope that you remember what is XML, and inside XML code we have some nodes with attributes or something else. And DOM builder use some elements, some objects with interface element. And we understand that these and these classes are the same semantically, but we can't change the interface of this element, maybe because we use some library and we have not any source code of this. But we, in this situation, we have duplicate code in this method and below and this method, because here we add some node and here we add some element, but these two objects have different interfaces. That's why here we have the same logic but with different implementations, and I don't like it. I want to refactor it, and here we can use special pattern. I hope that you know what is it, and it's adapter pattern. I think it's a very important pattern for backenders, for frontenders. In mobile applications, we use it sometimes. If we need to use some library and we don't like the interface of this library, but we can't change it, that's why we create adapter in which we hide the logic of working with some library or something else, and our system work with our adapter with interface what we like, and we don't change something in library. So we have this bad structure of our application. We want to use adapter to change it, and we will have, after refactoring, such structure of our program. We create interface XML node, and every class work with this interface. We implement this interface in tag node, but we can't implement it in element because we don't have the source code of this object. That's why we create adapter. It's a class in which we will have the object of this element, and this class has the same interface like tag node. It means that we should work with element adapter in the same variant as we work with tag node. And now we can remove these two methods, add below and add below, because they will be the same. They work with the same interface. And we can pull up this method into our abstract builder and remove the duplication code, because we create adapter and hide the logic of working with element inside this adapter. I hope that you understand how to read UML diagrams. So it's maybe complex method of refactoring, but sometimes we need it, especially if we use some library or some code which we can't change. I don't know why. Maybe because we have not any source code. Maybe because the team which create this element don't allow us to change their code. Maybe because a lot of parts of our system depends from this interface and we can't change it because we will break all our system. It can be different. So we can use this template when we have the same or similar actions, but with different interfaces. And if we can use this interface, like this element, we can just change this element. It's better to change it and not to use this adapter. Please remember it. If we can find the solution when we don't use the patterns, maybe sometimes it's better to select this solution. And this method of refactoring remove or reduce the duplication code, simplifies the code sometimes, but it can complicate the project if we can just change the code of our element interface or something else without pattern adapter. So it's the last example in this lesson. Now I can stop the record.